Let us look at the solution of this very interesting question. So what is this question? So find the value of limit n tends to infinity 1 by n square sigma 1 less than or equal to I less than j less than or equal to n tan inverse I by n into tan inverse j by n. So this is an example of what is called a dependent sigma. So the concept that is involved in this question is called dependent sigma. So when you have a double sigma type question, there are two kinds of double sigmas, which is dependent sigma and independent sigma. So sigma I equal to 1 to n, sigma j equal to 1 to n, f of I comma j. This is called the independent sigma. Okay, so what this means is you can think of a table or a matrix. Okay, you can think of a matrix where I goes from 1, 2, 3, 4, so on. I may represent the column numbers and j represents the row numbers. So I is independently going from 1 to n, j is independently going from 1 to n. So there are a total of n by n, that is n square boxes. So this box corresponds to I equal to 1, j equal to 1. This box corresponds to I equal to 2, j is equal to 1. So in each of these boxes, f of ij has certain value. So if you add all the elements of these boxes, so that is called sigma I equal to 1 to n, sigma j equal to 1 to n, f of I comma j. So that's called the independent sigma. Okay. So now in this matrix, if you see, these diagonal elements correspond to I equal to j elements. So in this, the elements in this diagonal corresponds to I equal to j. This box corresponds to I equal to j equal to 1, I equal to j equal to 2, I equal to j equal to 3, so on. The last box corresponds to I equal to j equal to n. Now the boxes above this corresponds to I greater than j, and the boxes below this main diagonal corresponds to I less than j. So if you are asked to find the summation of the complete box, it is called the independent sigma. I goes independently from 1 to n, j goes independently from 1 to n. Now here they are asking you to calculate only the summation of those boxes where I is less than j. That means they are asking you to summate the elements present in the lower triangle. So the general theory correspond to this is, okay, so there is something called symmetric expression. So there is a shortcut to find the dependent sigma based on independent sigma, where f of ij is symmetric. So f of I comma j is called symmetric if f of I comma j is same as f of j comma I. So if this expression is such that f of I comma j is same as f of j comma I, that is if I exchange I and j, if the expression is not changing, that's called a symmetric expression. So if it is a symmetric expression, then this matrix will turn out to be a symmetric matrix, because f of 2 comma 1 will be same as f of 1 comma 2. The element here and the element here turns out to be same, and the elements on above the diagonal will be same as the elements below the diagonal. So summation of these elements is same as summation of these elements. So if the expression in the double sigma is symmetric, then we can write sigma I equal to 1 to n, j equal to 1 to n, f of I comma j is equal to the diagonal element. The sum corresponds to diagonal elements, which is summation I equal to j f of I comma j, that is the summation of elements in the main diagonal, plus 2 times double sigma I less than j f of I comma j, or I greater than j. Both the summations will be same. So now if you want the summation of I less than j, so dependent sigma I less than j f of I comma j is equal to independent sigma f of I comma j minus I equal to j f of I comma j divided by 2. So usually independent sigma will be easy to calculate. The sum of diagonal elements is also easy to calculate. So if you subtract this by 2, you'll get the value of dependent sigma. So now in this question, I'm going to use this concept. So now you have limit n tends to infinity 1 by n square I less than j tan inverse of I by n into tan inverse of j by n is equal to, so now this is equal to limit n tends to infinity independent sigma I going from 1 to n, j going from 1 to n, 1 by n square tan inverse of I by n. Clearly you can see that this expression inside the double sigma is symmetric, because if you exchange I and j, the same expression remains. So tan inverse j by n minus sigma I equal to j. So if I equal to j, I can write j as I or I as j. So it will be 1 by n square tan inverse of I by n into tan inverse of I by n, tan inverse of I by n whole square, whole divided by 2. So this is what I'm going to calculate. So let us try to calculate this. Okay. So the given expression is double sigma independent I equal to 1 to n, j equal to 1 to n, 1 by n square tan inverse of I by n into tan inverse of j by n, as limit n tends to infinity. So this goes into definite integration as a limit of sum. So first what we can do in independent sigma is we can treat the variables as separate variables. When you do sigma with respect to j, I can be taken as constant. When you do sigma with respect to I, j can be taken as constant. So this is equal to limit n tends to infinity 1 by n square sigma I equal to 1 to n tan inverse of I by n. So when you do sigma with respect to j, this can be treated as constant and this can be taken out. Sigma j equal to 1 to n tan inverse of j by n. So out of 1 by n square, I give 1 by n to this and another 1 by n to this. So this is equal to limit n tends to infinity 1 by n sigma I equal to 1 to n tan inverse of I by n into 1 by n sigma j equal to 1 to n tan inverse of j by n. So now this limit n tends to infinity 1 by n sigma, this can be written as integration 0 to 1 tan inverse x dx, and this is also n, limit n tends to infinity 1 by n, this is also equal to 0 to 1 tan inverse of x dx, effectively integration 0 to 1 tan inverse of x dx whole square. So how do you do this? You can do this using by parts, u integral v. So integration of tan inverse x, u integral v minus integral of du by dx into integration of 1 is x dx. So this going from 0 to 1. So if you substitute the limits, 1 into tan inverse of 1 is pi by 4 minus of, so if you multiply and divide with 2, so you have dt by t. So minus 1 by 2 dt by t is ln t. So ln of 1 plus x square going from 0 to 1. So if you substitute the limits, this will be pi by 4 minus half ln 2. So this is the value of independent sigma. Then comes limit n tends to infinity 1 by n square sigma I equal to j equal to 1 to n tan inverse of I by n into tan inverse of I by n, tan inverse of I by n whole square, right? Clear? So this is equal to, so if you see limit n tends to infinity 1 by n times 1 by n sigma I equal to 1 to n tan inverse of I by n whole square. So if you apply the formula of definite integration as a limit of sum, this is equal to limit n tends to infinity 1 by n into integration 0 to 1 tan inverse of x whole square dx. So here I am not very much interested in calculating this, because whatever it is, this is a finite number. This is some number. This is a finite number, but this is being divided by n, which is n tending to infinity. So this is going to become 0. So you have the value of this, you have the value of this. So the value of the integral which is asked is pi by 4 minus half ln 2 minus 0 by 2. So which is equal to, so half of pi by 4 minus half ln 2, or 1/4 of pi by 2 minus ln 2. So let us see if that option is there. So half of pi by 2 minus ln 2 by 4. Is it whole square by chance? Did we miss something? Yeah, this is only integration 0 to 1 tan inverse of x dx. So there is one more. So you have this whole square minus 0 by 2. So half of pi by 4 minus half ln 2 whole square is the answer.